Hello, my friends. Today I thought we would start on activity 3, activity 2. So we need to, using the material covered in class, discuss the architecture of a typical subtractive synthesizer using graphic illustrations, audio, video to support it, and so forth. I'm just going to use this video for now. So we have a few components that we have to talk about. And if we scroll down and we look at the learning outcomes, we can see a little bit more detail on what we're expected to do. So describe the concept of architecture of a subtractive synth. So I'm going to start there. The basic concept of a subtractive synthesizer is in the name, subtractive. So it's called the source modifier model, which means that we start with a rich source and then we subtract from that source to get what we want. So the analogy would be like sculpting. So you might start with a very rich block of marble and you would chip away at it, or you would modify it until it takes the shape that you want. And so that's subtractive synthesizer. We have a source and then a series of modifiers. Okay, we look at the architecture of it now. So to be a subtractive synthesizer, you need to really follow a particular format, and that format was by and large developed by Bob Moog. There are other forms, but the Bob Moog format is what you would consider subtractive synthesis. And it basically means that you follow a path of VCO, VCF, and VCA, or in this case DC, because it's digital. So you'd start with your oscillator or your sound source, you'd go on to your filter or your modifier, and then you would amplify it. So filter it, and the sound source, you shape it, and then you give it some volume. So if we look at the architecture here, we can kind of break it down a little bit. We can see that there are two independent oscillators or tone generators, and they're controllable by an LFO, or kind of a modulator for vibrato, and a noise, and they can all be added together and mixed in a mixer. And that mixer can go to one of two filters. It can go into that filters in series, one after another, or parallel, both at the same time, or it can just go into one or the other filter. So you have two filters and you can connect them in different ways. You also have the same with the amp. The filter 1 can go to amp 1, or it can be routed through filter 2 and go to amp 2. So that's the way that works, and then the amps go straight to the output. So that's your architecture and the interface. So we're going to describe the basic modules, and we can see the basic modules as it wants to describe up here. The first one is the oscillator. So we'll just go and we'll look at the oscillator section here, and we can see it in a little more detail here. We can see that this particular oscillator has a few, wrong button, has a few controls on it. We can turn it on, we can turn it off, we can choose the volume, we can route it to one of the two filters, we can choose from one of 4 or 5 shapes available. There's no sawtooth on it, I believe. You can choose the octave, so that's your main octave, the semitone, there's 12 semitones per octave, and then you can detune the semitones. It's usually about plus or 3 semitones up or minus. If you click on that oscillator, you have access to an envelope, and you have access for pitch envelopes, so as you can make the oscillator raise or lower in pitch over time. And then you have options to access some more oscillator parameters, such as the pitch being controlled by the keyboard position, by the LFO, by the pulse width of an oscillator being controlled, and then we have sub and hard sync mode. So it's quite a fully featured oscillator, and the oscillator is basically the tone generator, and that's what it is. If you were working in an analog synth, you would really like rich sawtooths, rich sawtooths. Noise. If we look down here, we shall see some noise. So noise is usually just white noise or pink noise, broadband noise. This one is a little bit different. Usually you can just pick, I keep hitting the wrong button. Usually you can just pick whether it's white or pink or brown or whatever. But this one, it just gives you a filter. And so you can have various different types of colored noise using this filter. And noise is useful, useful for sound design like sea or wind or noise. There's noise in most voices. You can add a bit of noise to sound, hi-hats and things like that. It's useful. The next section is the filter, and the filter is going to be probably the most important part. The oscillators, the filters, and the amplifier. And the filters, if we look in here, is kind of complicated filter. The main parameters on the filter are going to be the frequency cutoff position and the resonance, a bit of more aggression around that frequency cutoff position. So you have a wide range of filters on this device. You have low pass filters, high pass filters, band pass filters, notch filters, band reject filters like a notch filter. So a low pass filter will let the low frequencies past the filter and it will stop high frequencies. They'll be in the stop band. High pass frequencies will do the opposite. They will stop low frequencies and let high frequencies pass the filter, and so on. And then the frequency cutoff position is the position, the frequency at which the cutoff begins. So in this one, frequencies above 189 will be reduced because it's letting the lows through, and it'll be reduced at 12 dB per octave, 2-pole filter. This filter then has an envelope, but we might talk about the envelopes in a little minute. The filter will just let you change the color of a sound, so you can make it more, add or remove frequencies. The amplifier. The amplifier is just a standard amplifier. It's got your volume and it's got your pan controller. You can control it with a little bit of level mod. You can turn it on and turn it off. Pan is obviously left and right. But these also have envelopes, and we're going to go on to envelopes now. So the envelopes are next. So we may as well look at this envelope. An envelope is used to describe a parameter over time. So this line here, it describes the travel or trajectory of that parameter. So for this, if we were to hook this particular line up, this envelope, to the volume, we could see that the volume would go up, and then it would go down, and then it would stay the same for as long as you're holding the key, and then when you let it go of the key, it would decay over this time to volume. And so if this line can be used to describe the volume if it's attached to the amplifier. But again, we have the similar type of control with the filter. So it has its own envelope, and we have a sort of an envelope for the pitch. So the envelopes let you shape the parameter over time. So for example, you could shape the dynamics of the amplifier over time, so as it starts quiet, gets louder, fades in, fades out, or is abruptly starts, and you do the same with the filter. So it starts dull, get brighter, starts brighter, gets dull. So you can kind of change a parameter over to, or pitch, you can start high, get low. There are also different types of envelopes. So this particular envelope has a few features. It has attack, decay, sustain, and release, which is an ADSR envelope, a standard envelope. This one has a sustained time, which is interesting. You don't often have that. And this one can go into either linear or exponential mode. So here you can see this hump, and that means that it's exponential. It's got a hump on it. If it was linear, there'd be straight lines. So that's an ADSR envelope, 4-stage envelopes with a sustained time. But you can just get 2-stage envelopes, an attack and a decay, AD envelopes, or 3-stage, an attack and a sustain and a decay. Or you could get, there's attack, hold. There's different types of envelopes you can get. You can also get an envelope where instead of just being a line with a couple of points on it, you can just draw in any line you want, and it's free, and you can have that. So that's their envelopes. And then we have LFOs. So an LFO stands for a low frequency oscillator. And here's an LFO here. And low frequency in this case usually means that the oscillations run at less than 20 hertz or 20 times a second. And what that'll do is it will, the same as the envelopes, it will control a parameter. But it'll be a slow rate because its top speed is about 20 times a second. So it could be like 1 or 2 times a second. So a much slower rate. And you can see that the parameter will go up and go down. So if I were to attach an LFO to the volume will go up and down, and that will create a kind of an amp tremolo effect, which is quite nice. If I was to attach this up and down movement using the LFO, if I was to attach that to the pitch, we get a vibrato effect because the pitch will be going up and down. If I was to attach this to the pan, I would get an auto pan because it would be going to the left and right speaker. So an LFO is just another modifier similar to the envelope. But we can attach it to different parameters. We can attach it to as many parameters as we want, really. The envelope will have multiple shapes as well. The LFO will have multiple shapes, square, triangle, like we've seen earlier on. But this particular one also has sample and hold, which is quite useful. It's kind of a random feature. And the last thing we have to talk about is the inverter, attenuator, and mixer. So all three in one. And they're usually going to be down here. So it's basically we do have an inverter just inverts a signal, and so you could see how this line here goes up. So if we were to attach this to the volume would increase in volume and then go down. But if I was to press a button and invert it, I could make it so as that the volume goes down. So this would be taking away rather than adding. So you can invert the envelopes or invert parameters. So when you go up, it's actually turning it down. It's quite useful sometimes. An attenuator is just, it's like a mixer. You can turn things up, turn things down. You attenuate the signal. And then a mixer allows you to mix multiple signals together. So, for example, we do have a mixer in this. It's kind of a hidden mixer, but you can see your volumes for the, if we zoom in on the oscillator section, you can see that there are volumes for the oscillator 1, the noise, the oscillator 2, and the routing of those oscillators. So there is a little hidden mixer in here that allows you to mix multiple signals together to get that rich kind of tone that you want. And then you can attenuate each of the individual signals going into that mixer, and then you can invert some of them if you want. So if we just run through it one more time, last time, okay? If we look now at the architecture this time, we can see our oscillators are tone generators, and we have a wide range of shapes and a wide range of controls, such as pitch envelopes, various LFOs, mod rates, sub signals, hard sync. We also have noise, and we can attenuate those signals, mix them together, add them all together, and once they're added in together, we can send them off to the filter. The filter, we can pick a particular type of filter, such as a low pass or a high pass or a band pass filter, and then we can remove certain or add certain sounds that we want. Well, we subtract, we don't add. So we remove certain sounds with the filter, we'll filter them out. And we have two filters in this particular synthesizer. The filters can, again, like the oscillators and the amplifiers, can be controlled or modified using envelopes and LFOs. And so the envelopes and LFOs will describe parameters over time, the way they change. And that's a synthesizer. That's a subtractive synthesizer, my friends. This video is my essay report. Thank you for watching. Bye now.